presentation is going to continue on wetlands. It's Kara Clark from the Moss Landing Marine Laboratories. She's been there for 10 years, and she's a wetland scientist, and she's going to report on the national survey.
And thanks to John, that was a great lead-in to my talk. I'm going to talk about the National Wetland Condition Assessment, which attempted to answer the question, how are our wetlands doing? The national assessment was conducted in 2011 across the entire contiguous United States. It didn't include Alaska or Hawaii or the territories. And I'm going to look in more detail at the California data. So just a brief outline, we'll look at the sites across the state. We'll talk about some of the rapid assessment methods that were used and some preliminary results, and then some next steps. An important caveat with the preliminary results is that I don't have the full data set yet from the EPA analysis, so the results that I'm showing are what was available to me now, but there will be more in the future. So this was the initial site selection, and the site selection was based on the U.S. Fish and Wildlife Service status and trends plots. And so the sites were only selected within these 4 square mile plots, which are scattered throughout the landscape across the country, but they are somewhat isolated in terms of their coverage. They don't really cover all of the wetlands that we have in California. And so as a result, the sites were somewhat clustered. There ended up being a lot of sites in the Bay Area, for example, which we'll zoom into in a minute. So we were concerned with this. We had 22 sites initially, and we thought, maybe if we could add more sites, then we would get a more robust representation of California's wetlands, and we would at least get more information. So we were able to wrestle up some funding to add more sites. And so we added these, what we call intensification sites. And so you can see they, in most cases, kind of overlapped with the sites that were already selected, but we did get a little more coverage and at least got a more extensive data set. So here is a zoomed in image into the Bay Area. You can see we had sites in several wetland complexes. One of them being Grizzly Island up here in the Delta. And then the Petaluma Marsh, we had several sites there. And then also a couple sites down in the South Bay in the Estuarine Marsh. Oh, and I should mention that this wetland survey included estuaries, depressional wetlands, slope wetlands, basically any types of wetlands. It also even included some wetlands associated with streams or rivers. The purpose wasn't to assess the streams themselves, but some of those were included in the sample frame. And there are other National Aquatic Resource Surveys that address rivers and streams, lakes, and coastal wetlands. The coastal wetlands are primarily subtidal, so this survey included the estuarine intertidal marshes. This is just a zoom in on Grizzly Island, that California Fish and Wildlife area. And so we had several sites in that area, which will come out later when we look at the stressors that, these wetlands were affected by. I think this selection of Grizzly Island had a big influence on that. So diving into the rapid assessment methods that we used, John set me up very well with explaining level 1, 2, and 3. And so we were really interested in using rapid assessment and also comparing it to the more intensive level 3 data that was collected as part of this national assessment. So we used both USARAM, which was developed in order to conduct this national survey. And then we also use CRAM, California Rapid Assessment Method, in addition to all the standard NWCA parameters, soil, algae, hydrology, water quality, vegetation surveys, and so on. So there's some differences between these two rapid assessment methods. USARAM is one method for any type of wetland, whereas CRAM has modules for different wetland types. So CRAM evaluates estuarine and depressional wetlands separately. USARAM gets a little bit finer resolution on the stressors. It quantifies stressors into 3 levels, whereas CRAM has a checklist of stressors that are present, and it has sort of 2 levels, they're present or really significantly negative. But both are categorized into 4 attributes of condition, which are shown here: the landscape, the hydrology, physical, and biotic structure. And for USARAM, the hydrology attribute only looks at hydrology stressors. And the USARAM separates its structure into stressors and condition metrics in general. But for hydrology, they only have the stressor metrics, primarily because they weren't really sure how to address condition of hydrology when it is so tied to the stressors affecting the system. So within each of these attributes, there are 1 or more metrics that are used to evaluate the system. So let's get into some data. So this is a cumulative frequency distribution showing depressional wetlands in red and estuarine wetlands in blue. And what these plots represent is, as you go up the plot, for example, I have the 50th percentile outlined here. So everything above this line, above the 50th percentile line, 50% of the sites score higher than than where that line hits the plot. So, for example, for depressional wetlands, the 50th percentile is at about 62, and for estuarine wetlands, the 50th percentile is at about 79. So in general, the further right on the plot, the better you're doing. So kind of the take home of this is that the estuarine wetlands, according to this survey, are in general in better condition than the depressional wetlands. And I think there are probably several reasons for that. One could be that the estuarine wetlands tend to be in large complexes, which don't necessarily have as many stressors acting upon them, particularly in the Bay Area, which have large expanses of salt marsh, whereas the depressions are often either more isolated or much more altered and manipulated in terms of moving water in and out of them or ditching them, that kind of thing. So this looks at the individual CRAM metrics. And the further out you are from the center, the higher the score. So again, it's contrasting estuarine and depressional. And you can see that for a couple of the metrics, the averages were about the same for interspersion and water source. But in general, especially in the hydrology metrics, the estuarine wetlands were doing much better than the depressional ones. So another thing I was really interested in was looking at stress versus condition. So in general, stressors act on a wetland and that can reduce the condition. So CRAM, most of the metrics measure condition, and looking at the relationship between CRAM condition metrics and USARAM stressor metrics may indicate the cause of low conditions. So we looked at some correlations on these plots. In general, for the first three, the top two and the bottom left, there's a CRAM metric on the y-axis and a USARAM stressor metric on the x-axis. And these were all significantly correlated, in some cases weakly, but significantly correlated. And then this last one is looking at two different stressor metrics, substrate stressors versus vegetation stressors, and they seem to be related, which makes sense. If you have a disturbance in the substrate, then you might get more invasive species or other vegetation stress. Oh, and I also wanted to point out, all of these plots represent 45 sites. It looks like not very many dots because the CRAM scores are, CRAM is graded on a scale of A, B, C, or D, so there are only 4 options, so it kind of falls out into those 4 options, but there actually is a lot of data there. Another thing that we were interested in, which didn't necessarily have the result we expected, but sometimes that's your result. We wanted to look at nutrients and toxins. The NWCA measured microcystin toxins. And so we thought possibly that with additional nutrients that are mixed in the water column that you might have more toxicity. But we actually didn't show any relationship. There was no significant relationship here. And these plots are the same data, except the bottom one has that outlier removed, so you can kind of see the spread of data. And nutrients are a major issue for California, as I'm sure you're all aware, both from agricultural and urban land uses. So I was curious to look at the nutrient content from this survey. And actually all the sites were fairly low. The units here are, it's nitrate and nitrite in micrograms per liter, and they were all below about half, except for one site that was up around 7 or 8. So that was kind of good to see. So moving on to the National Wetland Condition Assessment stressor data. So this plot looks at the acreage of stressor classes in California. It's an estimate of acreage. Each site was assigned a weight based on the sample design. So those weights are multiplied out to get total acreage. And you can see the most prevalent stressors in California, according to the survey, appear to be ditching and damming, as well as non-native vegetation. And then just to compare that to the data for the nation as a whole, take a note of the axes here. The max stressor data for California is over 60% of the acreage is affected by ditching or damming, whereas over here for the U.S. as a whole, the highest level is about under 30%. So according to this plot, California wetlands are subjected to a lot more stressors than the nation as a whole. But another interesting thing is that we do have less impacts from veg removal. For California, the veg removal metric was only about 25% or so, and then for the nation as a whole, it's up around 30. So I guess that stressor isn't as important in California. This is showing similar data, except it's broken down into classes. So low stress, moderate stress, high stress, and then only for this one stressor, non-native veg, they pulled out a very high stress category. So the reason you don't see purple in any of the other plots isn't because there wasn't very high stress, it's just because they didn't pull out that extra category. And again, similar story, ditching and damming and non-native veg are the most intensive stressors. And this gives you a better scale to compare to the nationwide data. And again, you can see that the California wetlands are subjected to greater stressors overall. So we're also interested in looking at validating rapid assessment method by comparing to level 3 data. This has been done in the past for CRAM. The original validation compared CRAM data to bird data and vegetation data and nutrient data. So some of the level 3 data sets that from NWCA that we could use include the plant indices. They've developed a multi-metric index based on the plant data for the nation as a whole and divided into regions, so we would be in the western region. There's water quality measurements, algal toxicity. We might be able to use the soil data, and there's lots of other data in there. There's some crazy number, like hundreds of thousands of data points were collected in this survey, so there's a lot of rich resource there. So this is just an example of correlating the nutrient, nitrate, nitrite data to the CRAM index score, which was significantly correlated. So next steps, we want to continue further comparing California data to the nation as a whole once I get the full data set, which is supposed to happen in the next couple of months. They're finishing up the final binning for USARAM, so right now they have the raw data for USARAM, but they need to assign scores for that. And then for each of the metrics and analytes, the national team is assigning good, fair, poor categories. So that will be really interesting once we get that translated into California. And then we really want to communicate the results of this survey to policymakers and the public. So we'll be attending the Water Quality Monitoring Council and possibly doing some media outreach and presenting to groups such as this. The next step is to plan for the 2016 survey. So these surveys happen in a 5-year rotation, and 2011 was the first one, so the next upcoming survey will be in 2016. As I mentioned in the beginning, we weren't extremely happy with the site selection, so we're hoping to discuss that with the EPA headquarters team and improve the sample frame so that we can get better representation. One possibility would be to use the best available maps, which for California would be CARI, the California Aquatic Resources Inventory. The other next step in planning is to choose the indicators and methods that are going to be used. And so they're in discussion of that right now. For example, the soil protocol was really intensive. You had to dig 4 soil pits at each site, so they're talking about maybe scaling that down a little bit, but still getting really useful data from it. And that's it. Thank you.
Time for a question or two.
I'm curious if the outliers you had to remove, were those from the same site or were they close together?
That's a good question, and I don't know. I'd have to look at it. Here? Here?
So Kara, looking at all the CRAM points on John's map, do you have plans to look at the distributions from the national assessment to the state CRAM database, which is a lot more extensive, and see if you see some of the same patterns?
Yeah, so actually that is one of our plans, is to attempt to extrapolate some of the NWCA level 3 values to other parts of the state that weren't sampled based on CRAM data that we have from that database. So yeah, I was actually curious about, someone talked to yesterday about the boosted regression tree, and I thought that it might be useful to to be able to project potential level 3 scores using